Assalamu alaikum everyone. I hope you all will be fine. Today we will discuss about the preparation of alkanes, that how we can prepare the alkanes from decarboxylation of monocarboxylic acids. So let's start our reaction and then its mechanism. So first of all, whenever we derive some kind of reactions and its mechanism, before deriving the mechanism and doing any kind of reaction, we have to make clear that what is the meaning of the statement of the reaction. Here is the statement, decarboxylation of monocarboxylic acids. Now what is the meaning of decarboxylation? Decarboxylation meaning removal of carbon dioxide gas. Monocarboxylic acids mean, mono means one. Monocarboxylic acids means those carboxylic acids which have only one carboxylic acid group as their functional group in their structures. So by understanding the statement means, here the removal of carbon dioxide from the monocarboxylic acid means having one carboxylic group. This is a carboxylic acid group. Carboxylic acid functional group. Okay, so first of all we will drive the reaction, that what is the reaction. Okay, so here is a general formula of carboxylic acid. Carboxylic acid, in the presence of sodium hydroxide, it will give us alkane plus sodium carbonate. Okay, so in the presence of calcium oxide. Fine. Okay, now we will derive its mechanism. That what is the mechanism? Remember one thing, to understand any kind of reaction, we have to understand that what is the mechanism behind this reaction. So first of all, in first make clear, R may be any kind of alkyl group. It may be methane, ethane, propane, etc. So first of all, propyl, first of all, maybe say that it is a methyl group. Here is a methyl group. Okay, and here is our carboxylic acid group. 1, 2, having 2 carbons means it is acetic acid. It will react with the sodium hydroxide in the first step. Now what will happen? Removal of water takes place. Hydrogen from here and hydroxide ion from here. H2O will be removed and sodium salt of acetic acid is formed. Okay, this is the sodium, as it is sodium salt of acetic acid. Now in the second step, this sodium salt of acetic acid will react with the soda lime. Soda lime means here is the sodium salt of acetic acid. It will react with the sodium hydroxide again in the presence of calcium oxide. Remember one thing, that sodium hydroxide and the calcium oxide, both these, this is quicklime and this is caustic soda, both they are given in the form of mixture. You can see in the granular mixture, okay, in the form of granules they are taken into the reaction mixture. So what will happen? So by going deeply into the reaction mechanism, this bond will shift over this oxygen. It will form negative, and here, as you know that carbon forms 4 valencies, means it forms 4 bonds to stabilize itself, but here are 3 bonds. It causes deficiency, or you can say instability of this carbon. So what will happen? The lone pairs over this oxygen, this will attack over here. For example, here, what will happen? This lone pair will attack over here, and in the form of bonding will take place from the oxygen, this oxygen, and here is, okay. So now it forms 3 bonds, 1 2 3. It causes instability of oxygen, as oxygen forms only 2 bonds, its valency is 2. So for removing this, what will happen? This will shift this bond over this hydrogen. Now meanwhile this bond shift over here, it forms double bond. Oxygen have double bond here, 3 2 3 4, 4 bonds, and this is extra 5. This will shift over this carbon, and now in the reaction mixture, this carbon will attack over this hydrogen, and during the rearrangement process, what will happen? Here alkane formed, and this is the CO3, Na2CO3, that is sodium carbonate, and here this is alkane. So this is the end product, alkane and sodium carbonate. So I hope you will understand the whole of its mechanism, that how this mechanism is carried out, and here is the rearrangement, how this rearrangement takes place and forms the sodium carbonate and alkane. So this was all about today's lecture. I hope you will learn something from this.